Welcome, everybody. Welcome to the March Colorado Springs Astronomical Society General Meeting. My name is Matt Russell. I am the president this year. I'd like to start by introducing our board of directors and executive committee. Vice president is Jim Urim. No, Jim's right in front of me. Yep, time for new glasses. Joe Berman, our treasurer, is not here this evening. Our secretary is Brent Goodman. He is right here. So I might as well say this right now. We have an attendance sheet in the back. And for visitors, please fill out the little visitor form so we can contact you later and see what you thought of the meeting. Members, it's important that you sign this visitor sheet. Our member at large is Dave Warner, right here. Our social director and public relations guru is George Way. He is right here. Floyd Glick, I don't think is here yet, but we do have another trustee in the room, and that is Scott Donnell, our ex-president. And then Stephen Paligo right here, our webmaster. And I don't think Vicky's here either this evening, so. You're right, stay with me. Okay, first off, we got to switch things up tonight for our meeting. So the way that it normally works is we do all the business items first, and then we take a break and then go to speakers. However, tonight, because of some prior commitments, our speaker needs to go at the beginning of the meeting. We're going to do some then committee reports, take a quick break, and then come back for things such as the observing reports, the outreach report, Dave's monthly What's Up segment. And then we have a very important announcement at the end of the meeting that I think all of you should stick around for because it's pretty significant. So with that, I want to thank the Space Foundation for allowing us to use their facility. They do that free of charge. And we just have to do a couple star parties for them a year. So thank you, Space Foundation. Tomorrow. So we will be talking about the star party tomorrow night in the outreach segment. So what I'd like to do now is I'd like to ask if we have any visitors here, people who haven't been here before, maybe once or twice. We got quite a few. Great. What I'd like you to do, if you wouldn't mind, is standing up, tell us who you are, what your interests are, and if there's anything that you're particularly looking for in a club such as ours.
So I have to stand?
Yes.
Yeah, you do.
Well, then if that's the rule, I don't want to be part of this. So my name is Mike Graham. I'm here with my son Devin. We're both into astronomy. My grandpa introduced me into astronomy. We have, we roast potatoes in his backyard. He'd bring out his telescope and show us the moon and Saturn, and something I grew up with, and now kind of passed it on to my son. And we heard about this public event that was free, and I believe you're part of our neighborhood, the Wagon Trails. He posted it on our Facebook page, and something just sounded interesting about it, so we're here.
Right on. Well, welcome.
Hey, and I'm really?
Let's go.
I'm going to speak on behalf of my son because there's no way he's going to do any public speaking. So, this is my son, Devin.
Let's go.
Yes, he does have a telescope. We bought him one for Christmas. Another reason why we're here is just to learn what's coming up, what's available, what's out there,
All right.
Where we can go to look at the stars.
All right, we'll be talking about that in a little bit.
Awesome.
Next.
My name is Benjamin, and I'm interested in looking at planets.
All right. Welcome.
My name is Don, Benjamin's dad. With his interest in looking at the planet, well, let me find him an organization that will afford him that opportunity.
All right. You're at the right spot. Next.
Hi, I'm Cody, bachelor's in astrophysics from the United States. Got here about 2 years ago, left all my stuff behind, so now I'm just trying to get back into it. It's been a while since I graduated. My job's not related, so kind of pulled me away from the field.
Did you say University of Madison?
Yes.
Madison, Wisconsin?
Yep.
Okay, cool. Just one last thing. Go Buckeyes.
Go blue.
All right. Yeah, all right, I just had to do that. We got a couple of Michigan people in here, so. Go ahead.
Hi everyone, my name's Kim. I'm mostly here with Cody, but I do have an interest in astronomy in college. Now that I've graduated, I kind of use it, so we'll see what this club's all about.
All right. Anybody else? All right, great. Well, I'm going to go ahead and we're going to get started with our featured speaker this evening. Stephen White is going to be talking about judging cosmic distances, correct?
Correct.
All right. Well, sir, you have the floor. There's going to be a lot of clicking.
Which one? Look at this, Mike. The answer is yes.
Yeah, maybe.
All right, so trying to get the click going. So one thing I noticed that we do at start parties, we would always tell people that the moon is 384,000 miles away, that the sun is 150 million miles away, that the Proxima Centauri, the closest star to us, is 4.2 light years away. M13 Hercules Globular Cluster is 25,000 light years away, and that the Milky Way galaxy is 2.5 million light years away. We would always tell people what we know, but we would never tell people how we know what we know. And that's what we're going to cover today with. Next page, please. All right, wait.
There's a donkey call.
The cosmic distance ladder.
Dramatic pause.
Look at that, you broke the mouse.
I broke everything.
All right.
I promise it does something. Yay! Not just what we know, but how we know what we know. Next slide. Right. So as astronomers, we use something called the cosmic distance ladder. There is not one main foolproof way to use to judge a distance to a star. Measuring distance accurately is one of the hardest things to do in astronomy. So what we have to do is we have to bootstrap it together. So how do we do it? Well, there's many different methods. First, we have radar ranging. Next, we have trigonometric parallax. Next, spectroscopic parallax, also known as main sequence fitting. Cepheid variables is our next one, followed by type 1a supernovae, and finally cosmological redshift. Next slide. Before I talk about what we know, I want to give credit, a little shout out to the ancient Greeks. They were really, really smart. The ancient Greek philosopher Eratosthenes, he was one of the first ones to calculate the circumference of the Earth. 2,200 years ago, he knew at the summer solstice that a well in Cyan
that the sun shone straight down that well. However, further up north in Alexandria, the sun did not shine straight down a well. There was actually a little bit of an angle. Based on this and knowing the distance between those two cities, he was actually able to have an idea of the circumference of the Earth. And it was actually pretty accurate for his time. Next, utilizing the knowledge of the size of the Earth and observing lunar eclipses, he was actually able to determine the distance between the Earth and the Moon. Followed by him is Aristarchus of Samos. Around the same time period, he was able to calculate the distance between the Earth to the Sun, as well as the Sun's size. Now, his measurements weren't particularly accurate, but that really didn't matter. His methods were extremely sound for this time. Later on, Hipparchus and Ptolemy further refined the distances. Now, I want to put this into perspective. The ancient Greeks knew the world was a sphere. They did this without satellites, without spaceships, without airplanes. Now, I don't know if you stay up with the conspiracy theorists that's going around, but the flat Earth theory, and I use that term theory extremely lightly because it is one of my pet peeves when people misuse the term theory. But there's a flat Earth movement going on in America, and it's actually been rising. It's been rising in the recent years that the world is flat. The ancient Greeks, 2,200 years ago, knew this. These ancient Greeks are actually smarter than many Americans, and that just blows my mind. Okay. So our first step on our cosmic distance ladder is radar ranging. Now, the ancients, for what they knew, they thought that the speed of light must have been infinite because every time a light hit, they thought, oh, it's instantaneous. Well, it's instantaneous on a small scale. Even Galileo tried to do experiments where he had a light source on a mountain, and then he was on a separate mountain a mile away. And the moment that light source went on, he saw it, and he's like, well, either light is instantaneous or it is so fast that humans at the time, modern man, could not figure it out. Well, in 1767, the Danish astronomer Ole Rommel, he actually observed Jupiter's moons, and he noticed something. He noticed that whenever Earth was close to Jupiter, the moon's eclipse were a little bit quicker than what it was calculated to be. But whenever the Earth was further away, the eclipses were slower than it was supposed to be. So he thought, you know what? That must mean it actually takes time for light to travel the distance between Jupiter and the Earth. And he did his calculations. And in 1700, he was only 0.5% off the true speed of light. His original calculation was 301,204.8 kilometers per second. So using modern equipment today, we know that the speed of light is 299,792.458 kilometers per second. And for us Americans, I leave in the miles right there for us since we're not with the rest of the world. Now, fun fact, if you ever wanted to know what a second was, 1 second is determined by 9,192,631,770 cycles of a cesium-133 atom. If you ever wondered how we calculate a second. All right, next slide, or next. All right, so the way we use this, what we do is since we know the speed of light extremely accurately, we shoot a laser from Earth or one of our satellites to the object. It reflects off the object and it comes back. Now, since we know the speed of light, we can use math and determine the distance that it took, or the distance to the object. Since we'll know the time, we know the speed, figure out how the distance for it. Next. Right? Now, this is good. This is really good for solar system objects, but it is extremely bad for really anything outside the solar system. If you think about it, our nearest star, Proxima Centauri, 4.2 light years away. It would take, we shoot a beam of light out, take 4.2 years for that light to get to the star. Reflects off the star, another 4.2 years back. And then we get it. One, we're moving in the solar system, we're moving in the galaxy is moving like And two, it would just take too long. There must be other ways. There must be other methods to use. But for radar ranging, next. Okay. Oh, fun fact, 1 light year is 9,460,730,472,580.8 kilometers, and it's a lot of miles. Next slide. All right, so radar ranging example. For each one of these, I'm going to give an example of the math that we use to figure out the distance to these objects. We shoot a laser beam from Earth to the sun, and it takes 16 minutes and 38 and some change seconds to reflect off the sun back to us. Next. So we transfer that into seconds, and that's 998 and some change seconds to go both ways. Well, we want to know the one-way trip, and that is 499 and some change seconds for that one-way trip for our laser. Next. Since we know the time it took for our laser to get there, and lasers travel at the speed of light, we do our little math, seconds cancel out, and the distance to the sun is 149 million, 597,870.7 kilometers. And as you saw, this is obviously not the scale distance-wise. Just wanted to show the size of the sun compared to little Earth. This is another fun fact slide. So, our galaxy, the Milky Way, is 100,000 light years across. And whenever I talk to some people, people ask, well, if there are really aliens out there, why haven't we heard from aliens? Now, I'm not saying aliens are the name and all that, but no, if there is another civilization out there, it would be extremely hard to know, because if you notice this little green white circle right there, that is the distance that our radio communications have gone since the 1920s. Almost 100 light years it's gone, and you see in comparison how small that is. So yes, we have SETI listening out there for other communications, but even if someone was to communicate from us from just midway through the galaxy, it would take tens of thousands of years just to hear that one transmission, even if that transmission was strong enough to get to us. So, little fun fact slide with shooting lasers and all that cool stuff. Next slide. All right. So, using lasers, that's out of the question outside the solar system. We need another method. So, if you graduated 10th grade geometry, you actually know the math to figure this out. It is trigonometric parallax. I will get that word right one day with my braces. I promise you. All right, next. So the astronomical unit, that is the unit that we use, or that we say is the distance between the Earth and the Sun. And I've already said it is the Earth's radius for the Sun is yeah, lots of kilometers, lots of miles, right there. Next. So we use the orbit of the Earth, or we use the orbit of the Earth as our base. So we know one radius, we know both radii. So now we know we have a base for our parallax. Next. Okay. So you have a close star that you want to measure. So you get the angle of that star in January. Next slide. 6 months later, you take another measurement. Next slide. And you create a triangle with this between the Earth, the Sun, and the star. Next slide. Now we're going to be talking about arc seconds. I want to just wrap your mind around how small that is. You hear 1 degree, that sounds small. Well, there's 60 minutes in a degree, and then there's 60 seconds in that minute for that degree. So whenever we say 1 arc second, that is 1/3600th of a degree. And also, that is also known as a parsec, not Han Solo and the Millennium Falcon Star Wars. If you want the backstory to that, I can tell you, because I'm a Star Wars fan, goes to Star Wars. But 1 parsec is 1 arc second of movement, and that is corresponds to 3.26 light years. And just to know how small this movement is, 1 arc second is equal to seeing a quarter move 5 kilometers away. So seeing 1/4 5 kilometers away, that's how much we're seeing these stars move. It's actually a lot less than that, as we'll see in the next slide. Or our formula for this is the distance to the star is equal to 1 divided by the parallax angle in arc seconds. Next slide. So we're going to use trigonometric parallax for Alpha Centauri. Next slide. So Alpha Centauri has a parallax angle of 0.742 arc seconds. Okay, we have our formula, distance divided by 1 over the parallax angle. Next slide. 1 divided by 0.42. Next slide. That gets your answer in parsecs, 1.35. Now, there are 3.26 light years in 1 parsec. So we do our little formula, parsecs cancel out, and we get the Alpha Centauri is 4.4 light years away, one of our closest stars. All right, so obviously we can see there's a challenge with this. Okay, next. The angles are really, really small, and the light must pass through our atmosphere. And there's a whole bunch of gunk in our atmosphere that shimmers the light, and it just makes precise measurements extremely hard. Next. So what we do, or what we can do, is go outside of the atmosphere. So we put satellites up in space. There's 2 satellites I want to hit on. First one is the Hipparcos satellite. 1989, 1993, it was able to get 100,000 different stars. It was able to measure the parallax of 100,000 stars within 1,600 light years. Next was the Gaia mission in 2013. It was able to determine the parallax angle of 1 billion stars in our galaxy, up to 30,000 light years away. 1 billion sounds like a big number, but it's in between 0.5% and 1% of all the stars in our galaxy. So even though we know the distance to 1 billion astronomical objects, really not that much knowledge. So we must use a different method. But what can we learn about these stars using trigonometric parallax? Well, we can calibrate the stars. Once we know the distance to the stars, we can calibrate how bright they actually are. That some stars are actually really, really bright. Some stars are really dim. Okay. Next, we can just fill this out. All right. Next. All right. So we can classify the stars. So we have the flux, or we have a little formula here. We have the flux. That is how much light is actually hitting our telescope. We have the luminosity, how bright the star actually is. And then we have the distance. And we have an inverse square law. We have the flux equals to the luminosity divided by 4 pi, the distance squared. Now, we took all those, we took 20,000 distances to stars, we mapped them out, we can plot. Now, you might think, well, stars are just random, they'll just be randomly when we plot the luminosity, the distance, the temperature, but it's actually not. We can actually find a pattern. Now, hey, right here. All right. So if you notice, the stars, they actually make a pretty nice pattern right here. We have bright, hot, luminous stars at the top, cool, dim, red stars at the bottom. We have bright, cool stars up here to the left, and we have dim, hot stars at the bottom. So we can actually do something with this. And well, that is the next step in our cosmic distance ladder. Spectroscopic parallax, also known as main sequence fitting. So we have 2 people, Hertzsprung and Russell. They decided that they're going to take this data and they're going to make a diagram with it. Okay? They decided that they're going to measure the color of stars. So they knew the luminosity. From the luminosity, you can determine the temperature. And by looking at it, you can determine the color. Plotting them down, you can just determine the radii of the star compared to the sun, and then the lifespan of the star. So you can take a group of stars and plot it on here, and you can determine a few different facts about them. So main sequence fitting is best, it is really used well with globular clusters and open clusters. With these clusters, the stars are they're essentially the same distance away. You can estimate the distance to the star cluster, you plot them on the HR diagram, and then you'll notice that the stars will actually line up either too low or too high. And then you actually just move the stars, move your data points until they actually fit this main sequence. Once they fit the main sequence, you can use a little bit of math, but you'll be able to determine how much you had to move the entire star cluster, and that will tell you how far away they are, those stars. And our formula for it is the log of the distance is equal to the distance modulus, which we'll talk about in a second, divided by 5 plus 1. Next slide. Okay. And I just want to show you that the graph Hertzsprung and Russell made, they based it off of those 20,000 different star objects, and they made this nice little poster that I can't find cheaper than $40 on eBay, and I really want one. Next slide. All right, so here's our example. We're going to take M45, the Pleiades. Okay? There are more than just the 7 sisters, the 7 stars in that star cluster. This graph represents 297 of those stars in the open star cluster. Next. Okay. So we plot these stars based on their brightness, their temperature, on the HR diagram. Now, if you notice this little green line in this handy-dandy program, okay, this line is actually, next, the main sequence line of the Hertzsprung-Russell diagram. And if you notice, these stars are actually below that line. That means they're dimmer, so that must mean they're further away than we originally plotted. Next slide. So we actually shift, there's pretty awesome programs where you can shift to where it actually fits the main sequence line. And this example, we have a distance modulus, which is the apparent brightness minus the absolute brightness of the stars. We have a distance modulus of 5.65, which we'll use a little bit later. We have our formula, the log of the distance is equal to, next slide, 5.65 divided by 5 plus 1, next. And we get log to the distance is 2.13, next. Okay. The anti-log of the distance, we get 136.258 parsecs, which gives us 444.2 light years to the Pleiades open star cluster. Now, let's see how this stacks up. Does this work? I know, like, I put stars on there, I put points, and I said, oh, you just shift them around, and it works. Trust me. Well, let's see if it actually works. Okay? So the Pleiades has a parallax angle of 0.007339 arc seconds. If we remember from our last slide, for our trigonometric parallax, our formula is distance equals 1 divided by the parallax angle. 1 divided by 0.007339 arc seconds gives us 136.258 parsecs. Survey says 444.2 light years. So we're confident that this main sequence fitting is accurate because it agrees with our trigonometric parallax formulas and answers. Excellent. All right. So, but there are some challenges with this. Next. So sometimes it's hard to say if we do an individual star. Is it really a dim, close star, or is it really bright, far away star? And if the group of stars are too far away, we can't resolve individual stars. So plotting the individual stars just can't do. This is good for star clusters up to 30,000 light years away. But if you notice, we're still inside of our Milky Way galaxy. We haven't even made it outside yet. And we're already 3 steps into it. Excellent. So there must be another way. And there is, with Cepheid variable stars. Next slide. So the person we have to credit this to is Henrietta Levin. In 1908, she was working at Harvard as a human computer. Now, back in the day, women were not allowed to look at the telescopes. The telescopes were too delicate to have a woman look at the telescopes. I don't actually believe that. Please don't crucify me or something. Or, sorry, Chelsea, don't hurt me when I get home. She's watching it live. All right. But what the women were told is, you don't have to look through the telescope, but here, have these tens of thousands of photos and look at them and see if you can make something out. Next slide. Well, she noticed that specifically in the small Magellanic Cloud and the large Magellanic Cloud, two small minor galaxies that orbit the Milky Way galaxy, she noticed that there are some stars that actually get brighter, get dimmer, brighter, and dimmer on a regular basis. And she noticed the brighter the stars, the longer it took. So she understood that, hey, if I see a pulsing star that goes really, really bright and then really, really dim, it took, or reverse that. If a star pulsed for so many days, she knew, hey, it must be brighter because it took so long for this star to pulse. And the pulsings last in between 1 day and 100 days. Next slide. So Hertzsprung, from the Hertzsprung-Russell diagram, he was like, you know what? I actually plotted some of these stars. I noticed them. So he went back to some of his work and he realized, whoa, that there were some stars that pulse. I already know the distance to these stars because at the time we didn't know the distance to the small and large Magellanic Cloud. They're outside of our galaxy. But Hertzsprung was able to determine, next slide, right? He was able to determine the distance to the stars, how long it took for the stars to pulse, and how bright these stars are. So knowing those three, he was like, well, so I know how bright they are, I know how long it takes, and I know the distance. I can actually figure stuff out. I can actually figure out distances to other galaxies. This is pretty cool. Now, Cepheid variables, they're very, very bright. They're tens of thousands as luminous, tens of thousands of times as luminous as our sun. Now, this is a good way to measure a few tens of millions of light years, up to about 50 million light years. But after that, even the Cepheid variables are not bright enough. Slide. So we have Hubble, the famous astronomer Hubble. He looked at the Andromeda Galaxy, and at this time, you have to remember, the 1920s, everybody thought the Milky Way galaxy is it. That is the entire universe, just our galaxy. All these other fuzzy things that we're looking at, they're just inside the Milky Way galaxy. They're orbiting it. They're really close. The galaxy is, or the universe is really, really, really small. But he was able to identify one Cepheid variable in at the time, the Andromeda Nebula. And this is variable 1, V1, in M31, the Andromeda Galaxy. You notice the period of this star was 31.4 days. And he went to his log chart right here, and he figured out at 31 days, it means that this star is 16,000 times as luminous as our sun. Now, the luminosity of our sun is 3.85 times 10 to the 26 watts. Next. So that means the luminosity of V1 is 6.2 times 10 to the 30th watts. And the flux, the amount of light that was hitting Hubble's telescope, not the Hubble telescope, just his telescope, was 1 times 10 to the negative 15 watts per square meter. So if we remember our little handy-dandy formula with flux, luminosity, and the distance, next slide, we flip the formula and get distance by itself. We know that distance is equal to the square root of the luminosity divided by 4 pi, the flux. So we plug in all of our knowledge right there, and we get approximately the distance to this to the Andromeda Galaxy is 2.3 times 10 to the 22 meters, which, if you do all the cool fancy math, it is 2.5 million light years to this galaxy. Now that blew everyone's mind at the time. At the time, they just thought our galaxy is it. But this one star, probably the most famous star in human history, this one star proved that there is more to the universe than just our galaxy. So supernova. Now this is, I think supernova is one of the coolest things because it has awesome explosions, lots of destruction. Haha, love it. All right, but supernova is when the most massive stars die. Slide. All right. So stars, they can burn their fuel between millions, billions, or even trillions of years, depending on how big they are. Now, the more massive stars, you would think, well, the most massive stars, they have more fuel. They can go on forever. Ha, ha, ha. No, they cannot. The more massive stars actually burn up their fuel faster than the smaller stars. think of it as a Prius versus an M1 Abrams tank, where one is you can go 100 miles per gallon, the other one you can go, yeah, you go 100 gallons per mile. Okay, that's not the exact number, but also it's like 16 gallons even started up. It's weird. But anyway, get off topic. So the most massive stars in between 8 to 20 times the mass of our sun. They burn up their fuel really, really fast. They go through hydrogen, turns into helium, turns into carbon, to oxygen. Then it gets to silicon. Now, whenever it gets to silicon, the days of the star are numbered. Because next, what it fuses is it tries to fuse iron. And with all the other elements before, those elements were able to produce more energy than it took in. However, with iron, it's the exact opposite. It sucks in all the energy. And so the star has nothing else to burn. It actually takes more energy to put in than it produces. So that forces the core to actually collapse in on itself. It goes from the core of the star goes from hundreds of miles to about a dozen miles almost instantly. That forces the star to collapse in on itself, and then there's a rebound effect. Depending on how big the star is, we're talking about under 20 times the mass of our sun. Because if it's more than 20 times the mass of the sun, it'll form a black hole, and that's another thing of awesomeness. But gravity always wins. Because when it's fusing, the fusion is pushing out on the star, keeping the pressure pushing out. Gravity's pulling everything in. Once fusion loses, pulls everything in, then explodes the star. Fun fact, this is actually how elements heavier than iron are formed in our galaxy. So have you ever thought, well, stars can't fuse past iron. Where do all the elements come from? Supernova. Next slide. Now, can we use a type of supernova as a standard candle? Well, I mean, I wouldn't be talking about it if we couldn't. So, yes, there is a special type of supernova, type 1A supernova, that we can use as a standard candle. Next slide. So type 1A supernova, it starts off as a binary star system. So it's two stars orbit around each other. One of the stars is about the same mass as our sun. Okay? One of them dies, and the other star starts its death, starts becoming a red giant, starts to expand. While that white dwarf starts to capture energy or matter from that other sun. Now, the original white dwarf, it must be less than 1.4 times the mass of our sun, and we'll see why that's important in a second. Okay? So the large star accretes material into the white dwarf. Now, this increases pressure into the white. This increases the mass of the white dwarf, which increases pressure, which actually causes fusion. Now, these white dwarfs, these are carbon stars, but the pressure and the mass actually starts that fusion of carbon. The electron degeneracy pressure, this is the stuff, if you will, that prevents the star from collapsing in on itself into a black hole. This now prevents the dwarf star from expanding. And now, because it's trying to fuse carbon, but it can't expand, but it must expand, something must give. Boom! And this happens whenever that star gets to 1.4 times the mass of our sun. Next slide. Because all of these stars are made of carbon, and because all these stars explode at 1.4 times the mass of the sun, that means almost all of these stars blow up at the same luminosity, about 4 billion times the luminosity of our sun. Next slide. We can use this to accurately judge hundreds of millions up to 1 billion light years away. To that point, even the mighty type 1A supernova is not bright enough. But let's see how we do the math on this one. Next slide. So we have a supernova, SN 2011 FE in M101. If you see right here, there is nothing. And then boom, supernova hit. And if you notice, supernova is almost as bright as the entire core of that galaxy. So the formula for the supernova is the absolute magnitude, which, since it always explodes at the same luminosity, it's always going to have the same brightness of negative 19.3. is equal to 5 plus the apparent brightness, how bright it is on Earth, minus 5 the log of the distance. Next slide. So our supernova here reached an apparent brightness of about 9.75 or plus 9.75. In this, the negative numbers are actually brighter than the positive numbers. So if you want to be really bright, you want to be in the negatives. Next. So we plug those numbers into our formula. Next slide. Next slide. Next log. We get distance equals 6 million parsecs. We multiply that by 3.26 light years divided equal to 1 parsec. We get that the distance to M101 is 48,327 light years away. Now, at 1 billion light years, like I said, these type 1A supernovae, they're not bright enough to be seen. So there must be something else. So we have 2 people in the 1920s. The priest, Belgian priest, George Lemaitre, I've seen LeMay, Lamont, I can't. Whatever his name is, he's a very famous guy, and I do no service to him by butchering his name. I apologize to him. And Hubble, they discovered that galaxies are actually moving away. Next. So this actually gave rise, hey, if the galaxies are moving away, that must mean at one point they were closer. So we want to see how fast are these galaxies moving away. Well, we can see that as things move away, you ever heard an ambulance, whenever it's coming towards you, it has a higher pitch, and whenever it's going away from you, it's lower pitch. Well, it's basically the same thing what you can do with light. You can actually break up light into its components, and you can see if things are moving away from you or if things are moving closer to you. So here, every element emits its own wavelength. So you can take a spectrometer, you can have a light source, and you can know, hey, I know what element is emitting that light. Every single one has its own unique fingerprint. So we can see when the elements are being radiated at rest, we can say, hey, this is its rest frame. We know that whenever it's not moving, this is the wavelength that it has. Now, if it's moving away from us, we see that all these lines right here are actually shifted to the right. It is shifting to the red portion of the visible light spectrum. Conversely, if something is moving towards us, all those wavelengths, all those lines are actually shifted to the blue side of the spectrum. Next slide. So we can actually determine if it's moving away from us or if it's moving closer to us. So we want to know if it's moving away or closer, and we have the redshift of light, denoted here by Z, is equal to the wavelength observed, so the wavelength that light has at rest, observed, so if it's moving, minus the wavelength at rest, divided by the wavelength at rest. So with this redshift, once we have that, we have the velocity is equal to the speed of light times the redshift. Next slide. I'm gonna have to speed it up a little bit. So hydrogen emission lines, normally, or whenever they're observed from a galaxy, they have a wavelength of 704 nanometers. We know that the rest wavelength of hydrogen is 653 nanometers. Next. We have our handy-dandy formula. We plug it in. That gives us a redshift of 0.07333. Next slide. So we plug in, we want to know how fast this galaxy is moving. We have the speed of light times our redshift. Next. We know that this galaxy is moving at almost 22,000 kilometers per second. Now, what can we do with this? Next slide. Hubble came up with something that's called Hubble's law. He identified that galaxies were moving away from us at a rate of 71 kilometers per second per megaparsecs. Okay. And he actually has a formula. Velocity is equal to the Hubble constant times the distance to this object. where if you flip it around, you get the distance is equal to the velocity divided by the Hubble constant. So in our example, our velocity of almost 22,000 kilometers per second, we have the Hubble constant of 71 kilometers per second per megaparsec. Next. We plug those into our little handy dandy formula. Next. We get an answer of, whenever you do all that fancy math, you get 1.01 billion light years to this galaxy. Next slide. Now, bonus points. Knowing the Hubble constant, we can actually determine the age of the universe. I think that's one of the coolest things ever. So next slide. So we can figure out the age of the universe. Velocity equals Hubble's constant times distance. Well, if we divide both sides by Hubble's constant and then divide both sides by velocity, we get 1 over the Hubble constant is equal to distance over velocity. Well, distance over velocity equals time. Next. So we have 1 divided by Hubble's constant. We know that 1 megaparsec is 3 times 10 to the 19 kilometers. Right? So we get 1 divided by 71 kilometers per second per megaparsec. 1 megaparsec is 3.0875 times 10 to the negative 9, or 10 to the 19. Plug that into our handy dandy formula. Next. So we get time, once we do all the math, sorry, I have to go fast here, is equal to about 13.77 billion light years. Congratulations. I just sped through the entire age of the universe. Okay. Next slide. Okay. So in conclusion, for the cosmic distance ladder, we are able to determine the distance to objects by radar ranging, trigonometric parallax, spectroscopic parallax, Cepheid variables, type 1a supernova, and cosmological redshift. Good thing about science, it is true whether you believe it or not. Any questions? No? Thank you. Yep.
What if the planet's made out of gas? How does it like?
It will still reflect.
How?
Based on the elements, everything that has color, and even though it is a gas, it will still reflect some things off that. So you ever drove at night in your parents' car through dense fog and they had their lights on and how you can see the light bouncing off of it? It's the same thing. Same thing happens. The light from your headlights are actually bouncing off the fog back into your eyes. Same principle. I know. It's awesome.
Just like this time. All right. Great. Thank you very much. Eric White would like to present you with the honorable mug that we give out every month for features. Okay, what we're going to do now is we are going to go ahead and move into committee reports. And the first report that we're going to give is the Rocky Mountain Star Stair. Tom, you ready?
Yes, now.
Yes, now.
We have some new folks in here. You're probably not familiar with what Rocky Mountain Star Stair is. We call it RMSS for short. That's a 5-day event we hold on the new moon weekend on our private 35-acre property near Gardner, Colorado. And that's coming up. We average 250, so people from all over the state and the country come in for this event. Beautiful location. Everything right now, I would say, is on schedule, on track. We have actually just yesterday, another vendor said, "Hey, can I show up and sell stuff?" So I think we're up to 6 vendors that are going to be on site. So that's great. Someone was concerned about the condition of the road. I want you to know that when you come off of Gardner Road and you turn into the subdivision where our property is, we've had some issues there. There's been some significant improvements made this spring. When you go up the hill, you know it's always been 2 fairly narrow, steep, rough roads. That middle section's been knocked out. It's been all smoothed out and widened, and so it's been dramatically improved. So if you're concerned about condition of the road, you're driving a little, car without a lot of clearance, it won't be a problem this year. Just so you know. We've got about 75 or so people signed up at this point. We still got you have about a month, what's today, the 20th? You got about a month than a week, or a month and a week and a half, or 2 weeks, before the registration fees go up. It will go up from 45, I think, to 65. So don't put it off too long, 60, 65. Don't put it off too long. Make sure, if you're planning to go, that you get your registration in on the rmss.org website. Anybody got questions? We're trying to do this quick because we've got a big special topic coming up at the end.
Great, thank you, Tom. Appreciate it. Next up, we have an astrophotography special interest group. Brian Gibson is the leader of that group. So Brian, if you could tell the new folks here this evening what your group does and what's upcoming.
Yeah, we meet 1 week after tonight, so next Tuesday, we meet at my home. If it's something you're interested in, please get me your email address and I'll put you on the mailing list and give you details on what's being covered. This next week, we're studying a very kind of an interesting concept. One has to do with what we call wavelets and deconvolution, which is processes that will bring out outstanding results in your processing of your images. So we're going to try to play with that, have some fun with that. And again, name and email, and I'll be glad to put you on that list. Thank you.
Thank you very much. Public relations, George White, do you have something to say?
From the PR side, on Facebook, we're up to 1,684 followers. For us, RMSS is about 280 out on Twitter, 1,150 and change for CSAS, about 850 for RMSS. The one thing I did want to point out, where's Ron? I know you're here. There's Ron, stand up. In the back there, that's Ron Sparkman. Hey, so Ron is a DJ working on his degree in astrophysics. And he has started up a website, it was opportunityU.com, and he has changed over to Stardom Space and Science. And we are kind of partnering with Ron. Ron came to us, approached me, asked Eric and I to participate in some basic astronomy videos to go out on his website. We actually filmed the first 5 of those about 2 weeks ago here at the Space Foundation. We're going to be doing some more depending on how they go over. And he's been kind enough to allow us to advertise CSAS. So if you go to his website when they come out, which will be next month, hopefully maybe sometime, you'll be able to see some cool stuff. And Eric and I talking basic astronomy, target audience of kids and first timers. And, you know, CS Astro's mentioned, Space Foundation's mentioned. So I want to give a shout out to Ron and say thanks for the opportunity. It's going to give us some good visibility and hopefully bring in some more folks. And that's what the PR business is all about. Thank you, Ron.
And thanks to them, they did all the scripts and everything for it. They did an amazing job for all the telescopes and everything. So it was a Space Foundation. Without them or the Space Foundation, we couldn't. So thank you guys for teaching me a ton along the way as well.
Yeah, the website is startupspace.com.
George, one other thing.
Summer picnic. Summer picnic is this summer sometime. What do we say? August 4th. August 4th out at Black Forest Park. We'll have the pavilion out there like we always do. You'll see sign-up sheets as we get a little bit further into the season. So come on out. It's on us.
Gotta have a permit.
Dave will get that for you.
Thanks, Dave.
All right. Next, Jason Furman, our Starry Meadows chairperson, was unable to be here this evening, so I'm going to kind of give an update that he has given me. First off, is there's been significant improvements with the relationship with our neighbors in the Starry Meadows area. Jason had a chance to go down to the property. He met with the Dolores, which are the neighbors to the north, I'm correct, and discussed some of the issues regarding the HOA complaint that was made at the end of last year. He's made some significant improvements there. Out of that improvement, it appears that we are going to be getting power access from one of our neighbors for grid power versus bringing it an extra 1,000 to 2,000 feet from the road. So we're working that deal. Which would hopefully save us quite a bit of money on that front. One thing regarding this complaint that we've been talking about, and trust me, I don't want to deal with this issue, but we have to. And the board and executive committee has made a directive. So if there's anybody that has looked at our forums, I listed that directive on our forums. What it pertains to is the long-term storage of trailers on the property, whether it be a camper, whether it be a storage trailer, whether it be an RV. What the board has decided is twofold. Number one, we've instructed the Starry Meadows Committee to come up with a membership usage policy that is fair to everybody. What to expect in that is is typically what you would see in RMSS. You know, no campfires. There's certain things you can't do. There also will be some requirements for trailer storage. Hopefully it will be a little bit more expansive than the directive that we have just said, which is basically if you have a trailer down there, you can't leave it. We're dealing with a bunch of political issues with the neighbors. Those are starting to bear some fruit, which we're going to try to maintain. We're going to try to build those relationships. So we're asking membership to bear with us while this process plays out. I have spoken with several individuals that are very concerned about the trailer usage and long-term storage on the property. The Starry Meadows Committee will be meeting in April. This is the time to show up at that meeting if you want to discuss this, because they are going to be making recommendations to the board on how to proceed and what to proceed with. So, is there any questions on that? No questions? Okay, great. So what we're going to do is we're going to take about a 10-minute break, and then we're going to come back and we're going to do our nifty outreach reports. Scott Donnell also has a little presentation he's going to do. Is that part of observing reports? Observing reports. Fred is always telling me, if you're a visitor, please fill out the little card for the visitor form or sign our attendance sheet. And then we have a very substantial big announcement towards the end of this meeting. I think everybody wants to stick around for it. So we'll come back here at 1940. Be here.
Well, because we should be before every single time. But we should.
Okay, folks, if you would, if you could, please take your seats. We got to get going on a couple of things. We're going to start off by having Dave do talk about outreach and then go right into his what's up presentation for the month.
Yeah, so Stephen, if you could put up the calendar from the webpage for April, but I'm going to talk about first where we're at so far this year with our outreach. We are currently we've done 18 events with 1,772 people reached. So, in the middle of last month, we did, I told you we were going to do it. We did. We went to Dinosaur Resource Center up in Woodland Park, the Rocky Mountain Dinosaur Center. And we had a free Scout Day. That's 550 of those people was a Scout Day. We did Dry Ice Comets. We had two different groups, Doug Cook and his wife Elizabeth, and Bruce had meteorite displays and talking about the meteorites, and then Jacob and Ann helped out with doing a crater demonstration. We had a table set up with giveaways. I had a whole box of stuff sent from NASA JPL and the NASA Space Place of calendars from NASA to give away. So reached a lot of people and had a great time. It was a lot of fun. We look forward to doing it again. They want us back as soon as possible. They're like, can you come next month? You know, we can't. We got a lot of things going on. As you can see, if we look into we have the real quickly the Pikes Peak Community College events we have coming up on the 2nd of April. We got the Pikes Peak Community College Rampart Range campus, and then down we have the Centennial campus. And we're going to talk about doubling up on events here in a minute. And then downtown, in a little park downtown, we have the downtown campus. So we're going to do those events. That helps out the Pikes Peak Community College folks. Some of those young students were at our event at Palmer Park on Friday night, which is also very successful, by the way, with 19 telescopes and 3 cameras and binoculars and about 100 people. So, and we had some of those students that we were able to help out in getting their questions answered on their form. So anyway, that's going on. But tomorrow night, we do have a start party at the Space Foundation Discovery Center. It's 6 to 8 p.m. Yes, it's still daylight, but we'll have a full moon or near full moon up in the skies. Maybe we'll find Venus, but probably not because it's probably be cloudy. But hey, it's going to be clear because I said that now. So come out, help us with the Space Foundation start party. Even if it's just to hand out brochures about our club and about what other start parties you can come to when it isn't cloudy or whatever. There's going to be things for us that we can do. If you can help out, come out, and we'll have all sorts of different activities and things to make sure that the YMCA folks that are on spring break coming out here, have a good time. We'll be able to be part of that and show our CSAS spirit with, maybe we'll show them the moon too. So if we can go back to April real quick, and I'll finish up because I do have to get quick. Florison Fossil Beds on the 13th of April. That Friday, you'll see we're doubled up. Bruce is going to go up to Florison. I'm going with a couple other people to Broadmoor for a start party. That's one of our fundraising type events that we do with them. Bruce is doing the Fossil Craft Beer Company Astro Talk. You can see where that is, where that beer brewery is on the website. And I'm going to go to the Centennial campus along with anybody else who wants to join me out there with our telescopes. It's a great place to go. And then we have the Space Foundation, the Space Symposium coming up. I'm going to get more info on that when I do. I'll post it. And then we have our International Astronomy Day on the 21st of April. That's basically daytime from 9 to 4, we're going to be set up with solar telescopes outside the visitor center. And then we'll have 1 or 2 maybe activities, a lot less than what we did the last astronomy day. And then from 8 o'clock to 10 o'clock at night, we'll do our star party. That's our normal monthly star party we'll do at Garden of the Gods in the RV bus parking area like we've done before. So what we have left from there is we got our meeting coming up, and I'll talk about it. I'm just doing Jack Swigert Aerospace. We're doing some solar observing and activities in the daytime. The elementary school out at Fort Carson is Patriot Elementary. We're doing a STEM night out there that same week, and then that takes us through the month of April. So that's pretty much what we've got for outreach. Sounds like a lot. It is a lot, but it's also a lot of fun. And come out and join us if you can. Thank you.
Dave, I got a question. You had mentioned, when is our Space Foundation?
It's on the calendar there. It's the 18th of April. From 6 to 10 p.m. And as I get more info on that, which I'll get from the Space Symposium guys about where to be, how to get set up, and who can participate,
we don't have a Space Foundation thing this week?
Tomorrow. No, we have one tomorrow from 6 to 8 tomorrow here at the Discovery Center. We'll set our telescopes up right outside.
Do you have enough help for that?
Yes.
Okay.
Yeah. So, okay. So that's it for that, and then I'll go right into the what's up. So I don't have a, what's that? What's up? Right. I did say I had a roommate from East LA when I was in college, and that's what we always say to each other was what's up. But it was fun. College was great. So what is there to see? This is now my what's up presentation for April 2018. So what is there to see? Well, we have, first, before I get into this, we have Venus that's up in the sky after sunset. It sets at 8:45. That'll continuously get later and later in the evening as we move on. Mars, right now, this is as of today, so you can add a couple of minutes onto it. It's getting earlier all the time. Mars is now up, starting to rise in the east at 11:41 p.m., Jupiter at 11 p.m., and Saturn at midnight. So all these planets, I know somebody back in the back was saying, hey, we want to look at planets. Right now, they're still coming up in the morning time, but each night they're getting into that evening hour, so not before too long, they'll be part of our star party events. So I'm looking forward to those planets as well. But in March, other than Venus, we're pretty much devoid of the planets during the early hours. We have March 28th, which is tomorrow night or the night after. We have Regulus only a degree south of the moon, and Venus is only 0.7 degrees or 0.7 degrees south of Uranus. That would be difficult to see again because it'll be in the as sunset is occurring. But it's something you can go look at on March 28th if the weather's nice. On the 31st, we have our second full moon of the month of March. It's actually our last full moon, double full moon until 2037. So, hey, get out, go see that full moon that we're going to see tomorrow night at the Space Foundation star party we're going to do tomorrow night here. Not quite a full moon, but close. Little factoid for you. That full moon is the sap moon or the maple sap moon because it's the time when the sap starts to flow in the trees. If we had a regular springtime for our folks in the Northeast, but it also fixes the date of Easter. It's the Sunday after the equinox, after the full moon. So that gives us this year. It's on April 1st. So next slide. What is there in April? On April 1st, Mars is only a degree and some from Saturn. They form actually on April 7th, Saturn, Mars, and Moon form a triangle. So you have a nice little good photo opportunity for you on April 7th for your wide field camera gurus out there that want to take a picture. I wanted to throw this up here. We'll see what it catches. How about April 14th, 15th is New Moon Weekend. So if you got good clear weather, it might be a good time to go down and check out Starry Meadows and go do some of that observing in those dark skies. So think about New Moon Weekend. Maybe it'll start, warming up and be a nice warm weekend and clear. April 22nd, Lyraid meteors peak. It's about 18 meteors an hour in the appearing to radiate from the constellation Lyra. So, and then April 23rd, you have the moon 1.9 degrees south of the Beehive, which is M44. And lastly, if you go to the last slide, key areas in the sky for observation, just a suggestion. Right now, Leo is coming up, getting high in the sky. Look for those Leo triplets, which is M65 and M66. These are all of the galaxies, NGC 3628. Really awesome to see, and especially in dark sky sites. Not so good at places like Palmer Park, but we tried. And then the Leo pair, M95, M96, also at the base of, at the feet of Leo. And then in Ursa Major, we have the Owl Nebula M97, the Galaxy M108, with no parentheses at the end. And then galaxies M81 and M82, which are always popular things for us to look at and just enjoy their beauty, especially at our dark sky locations, wherever that might be. So that's what I have for you this month in What's Up in the Night. Thank you.
Okay, well, we're moving on to observing reports. Scott, would you like to make your presentation?
Yeah. Steven, can I use the laser pointer on that? I don't need the clicker, just the laser pointer for it. Please. Which is. All right. So, my observing report. A few weeks ago, on or about the 1st of March, I was sitting at work and I got an email that came in from David Dunham of the International Occultation Timing Association. And he and a couple of other people were in the Denver area, and there's an occultation that evening of the asteroid 1997 UV14 by a 5.5 magnitude star 133 target. So in the email, he said, "Hey Scott, see that you've got a station. It's going to be like on the southern end of this thing. Would you be able to participate?" So I said, why not? So I did. Next slide, please. So for those of you that aren't too familiar with asteroid occultations, they're essentially when an asteroid in our solar system passes in front of a distant star and blocks out that light momentarily, a second, maybe up to 5 seconds or thereabouts. And if you have a series of observers positioned properly, it's possible when you aggregate the different observers' observations about when the star winked out and came back in, you could actually get information about the size and shape of the asteroid. So the prediction was for the visibility track. It's not unlike a solar eclipse. It's a very narrow track. And, so seen from the western United States, it was at an elevation angle looking toward the west of about just a little bit less than 20 degrees. Next slide. And so, oops, I hit the wrong button. Could you go back? Thank you. One more. There we go. And there we go. Okay, so this is just kind of the, showing the track again. And there's my observatory sitting right here. So the two solid white lines represent the, predicted path. And then these outer lines are like the 1 sigma uncertainty. So the path could have shifted north, could have shifted south. It's possible that I could have been positioned right there to actually be in the path. So that's why you want me to observe it. So I did. Next slide. So I utilized a method called drift scan. And really what it is just at the a few seconds before the predicted time of the occultation to a few seconds after, you just turn off the clock drive, and so you get the drift of the star across the field of view of the image. And it was right about in here was the expected event. David Dunham did see something he was up near Elbert, I think, or no, up near Bennett, Colorado, and he found something around this time. And as you look at that, you say, well, did I see something as well? So here's kind of the blow up, and I was suspicious. I'm thinking, I don't know. I don't think that's really anything. I had Matt convinced that it was something. So I sent it off. I sent it off to John Bronham with the IOTA, and he has this software called Scanalyzer. So he ran it through, and he thought that this dip right here might be a possible event. And so we kind of reported it. I ultimately submitted a report that said, yeah, maybe. I don't know. It's a possible. That's about it. So. Then a couple days later, I get the email after they've kind of sorted through this. Next slide. I'm sorry. So this was like some of the other observers. And so David Dunham was right along this track, and this is me out here on this green line. And so this is like where I saw something, David saw something here, nobody else saw anything. And so based on the expected size and shape of this asteroid, they felt that I was just too far away. It couldn't possibly be that large and that distended. So anyway, now the next and last slide. So the last thing was I get this email that says, some guy named Brad, he says, here's the reports for the 3 stations. The positive observation is at Dunham 4. That's the one that was up near Bennett. He had a 0.9-second event, and then I put in yellow. He also attaches a report for me, my observation based on John Grove's Scandalizer analysis, blah, 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 shows that John shows a significant drop near the Dunham 4 time, but it's probably just scintillation. So, not much deeper than other noise spikes. So that's about the end of that. So, science is not always about success. Sometimes it's just trying. And in this case, I just wanted to share with you my attempt, but I tell you there will be other attempts as well. So that's it. That's all I have.
We asked for. That's pretty cool, though. Is there anybody else that has any observing reports that they'd like to?
I do. I have one. I'm sorry. I just didn't want to forget about it because it was pretty cool. I had an observing point, and sometimes, like science isn't about whatever he said. Outreach isn't all about observing. But I observed something on the night that we went out to Forest on fossil beds. Had a great dark sky night. But something really cool happened. And Jacob and Caitlin, you guys want to tell the group what happened at Forest on fossil beds?
It was pretty clear out. I've been working on it for a while. But I went ahead and proposed to Caitlin.
Yeah. You fool! You fool! Hey, she's still here, so that's a good thing, right? All right. What I want to do is I want to move into our last segment for this evening. And what I've done is I created a little brief introduction to this. What I'm calling this is the Colorado Springs Astronomical Society Transformation. I've been a member since 2001. There's a lot of members here that have been a member a lot longer than me. Tom, Mike Frazier, Schlafly, just to name a couple, Devin. Over the last 10 years or so, a lot of us have seen a very, very substantial transformation of this club, going from 40 members, 30 members, 60 members, on up now to, I think, 160 members. So we've doubled in that time frame. And as a president, one of the things I was looking back at is I'm like, okay, when did this start happening? And really what I think we can do is we can thank the Forest Service for this transformation. And for those of you that have been here a long time, you know exactly what I'm talking about. We were a happy-go-lucky club, having our Rocky Mountain Star Stair on public lands. And then Alan Gorski and I were, with Art DeBrito, were helping run the Star Stair. And the Forest Service started jerking us around with rules, policies of the moment, and just really making this event a real struggle to have on Forest Service property. We presented to the club that, hey, the writing's on the wall. We can go several ways with this. We can either have the initiative to do something, or we could stay with them and just have a miserable event. So that was really where I thought that this change started happening. Over the last couple of years, I'm sure a lot of you members have seen, is that our outreach is way up. Mr. Rockstar Outreach guy right here. Right? I know Bruce is not here. He is listening tonight. Him and Hal Bidlack have been doing a ton of KRCC, that's the station, right? Weekly astronomy chats. What's it called? Is it?
Yeah, astronomy podcast.
Looking up. Okay. We've had awesome media access. One event that comes to mind is when we were at Wyoming and the Fox News crew showed up and introduced themselves and interviewed a bunch of our members and live and did a lot of streaming back here at the Springs.
The fact that we were asked by them to come up.
Exactly. So we have those positive relationships, and they just keep growing. Relationships in the area. Space Foundation, Garden of the Gods, Fluorescent Fossil Beds, Bear Creek Nature Center, the Dinosaur Museum, United States Air Force Academy. I can go on and on with probably 40 more entities like that we've partnered with, that have the relationships have just blossomed and bloomed. And I mean, we're going places with this. Our organization, with our board, our committees, Starry Meadows Committee, the board, everybody is now thinking long-term master plan. You know, what are we going to do? What's happened? A long time ago, it wasn't like that. It was kind of like, okay, well, let's do this and go with that. I had a great conversation with David the other night regarding some things that he wants to do with outreach, such as training other individuals. I mean, to help with that don't feel comfortable doing it. So, I mean, that's really cool stuff. So, we got here not just because of one person, not because of a talking head. We got here because the membership has had a transformation, and they've made it a priority to do neat things, to commit time, to commit energy, to commit resources. All these pieces are coming together. And when that happens, big things are going to happen. I knew before I was running that something was just around the corner. I mentioned it at our first board meeting. I thought something was in the works. I think others kind of probably had that gut feeling as well. So what I'd like to say is we've had a really big opportunity drop on our doorstep. And with all this work that we've done, we've been noticed. So, I mean, that is really cool. Last month, I introduced Devin Delarose from the United States Air Force Academy. He gave a brief introduction on what is going on with the observatory at the Air Force Academy and a upgraded telescope. That sounds pretty darn neat. What I didn't mention is that they have an existing telescope in that observatory. It is going to be removed. It is going to be removed in May. Is that still correct? Timeline? Yep. And there's a very good chance that it is going to be scrapped. From what I understood, correct.
If it didn't find another home.
If it didn't find another home. This is a 24-inch Baller and Chivens telescope. It was commissioned in 1965. Devin is going to be getting up here in a little bit and explaining some of the specifics on that telescope. It's substantially large. 20 to 25 feet if it's sticking straight up in there, maybe. Weighs 6,500 pounds. It has high value. It has, in terms of worth, outreach potential, or perhaps the rich history goes along with it. The U.S. Air Force Academy has approached us with becoming a beneficiary of this telescope. Okay? From what I understand, and Devin can account for this or strike me down, from what I understand, we are the only outfit that they considered for this endeavor because of what we have as a group have been able to accomplish over the last 10 to 12 years. Okay? It didn't happen by chance. It happened because of our members. So as a club, we need to answer quite a few questions. Okay. we need to, one thing I want to say is, remember, how many of you were here last month? How many of you remember that video at the beginning of the meeting that I showed of the Minnesota Astronomical Society's gear? Okay? Okay? That was pretty impressive. So what we need to do as a club, and I think with everything that's going on and this sort of opportunity coming to the table, is that I think we need to determine how are we going to get to the next level? Does the membership want to even get to that next level? It's a very valid question. What is the next level? It may not necessarily be this opportunity. It might be something like what the Minnesota Club has. It might be something completely different. We don't know. We need to find that out. Another option is the next level. Do we go with the status quo and call it a day? That's the bottom line. If there's a desire to get to that next level, we need to determine a couple things. Is this offer right for our club? Okay. Does it meet our objectives as defined in our bylaws? We have specific objectives that have been in place for 30 plus years. If so, how do we make it happen? If we want to make it happen. Or if we can't make it happen, can we find someone who can? So those are all questions that I want you guys to think about over the next couple months. Our board met last Tuesday, and we have decided on several different things. We've been discussing this project now for almost 2 months, correct, end of January. The first thing about this idea and this opportunity is that we realized that this Scopes home is in Colorado Springs. There were some members that were very insistent, or they really wanted this scope to be done in Star Meadows. From a board perspective, and as a president's perspective, we decided that we could not move forward in that realm. The reason being is because A, if we were to do that, the financial cost to this would almost 100% be burdened upon the members. And there's a lot of questions that we have right now regarding the cost of this. The board could not put our solvency in jeopardy. And I think that everybody would understand that. As I said, this telescope's home has been in Colorado Springs for how many years? 40. 4 years, okay? If we are to go and acquire grants, which we've been throwing around the term grant for quite a long time, we will need to do that in this area because grants typically are awarded in bigger areas that fund projects within that area, not funding a project that's 150 miles from here out in the middle of nowhere. Okay, that's what we have to do. So the board has decided that we cannot or will not place this telescope in Starry Meadows. That was voted on, and it was a unanimous decision. Secondly, what we've done is we have decided as a board and voted on creating a planning committee for this particular project. And I also would like to see this project or this committee actually also help form some long-term objectives if that's actually what we want to do. If we want to get to a level where we can perhaps have this telescope, think about what needs to be done, or what is our vision in the future, more of a long-term vision. We need that for our grant writing as well. Because if we go and try to submit for grant money, that's one of the questions I ask. Well, what is your long-term goals? What are your short-term goals? What do you want to do? And if we don't have vision, they're just going to look at us and say, there's the door, buddy. I mean, bottom line, that's what they're going to do. So the issue that I mentioned real quickly was that the United States Air Force Academy is looking for us to take this telescope. They're taking it down in May, which it could possibly go to the lumberyard and be scrapped at that point. So the board made one more action, and that was to write a letter of intent. Basically, it's a mode of operation stating that over the next 12 months, we as a club will decide if we can take this project on. That'll give our committee time to research our long-term goals. It'll allow our committee to get estimates together. It will allow our committee also to perhaps start approaching entities in the Colorado Springs area. State parks, national monument parks, county parks, wherever. Nothing's on the table, off the table. This committee needs to be able to perhaps decide or help with that vision and get us narrowed down. Right now, everything's kind of wide. They need to bring this path in and get it closed. It will need to be presented to the board. It'll need to be presented to the membership. With this letter of intent, what we are asking, we're asking the U.S. Air Force Academy to put this telescope in storage, to store it for 12 months for us so that we can get our ducks in a row. At that point, if we need more time, we can ask for that time. Now, it may not be given, but it might. It sounds like it might.
Yeah.
Okay. We also want to obviously get the full history on this telescope, such as mechanical history and all that stuff, and the value history. The history, not just the history in terms of mechanical worth, but the history in it itself. So, key that we also had in this letter of intent, which we have not submitted yet, is that at this point, no financial hardship on our club. This is more or less a research time, a time to figure out what we want to do, if anything. At a later time, financial issues will be discussed if we need to go down that road. So that's kind of where we set with this. I'm just curious. Does this interest anybody? Yeah. Okay. Okay. Just wanted to make sure. So, yeah, Devin, just Devin too, because he gets that old scope out of it. But no, I'm just kidding. But anyway, Devin is here tonight to talk about this scope. Is there many people here who have seen it? Several have. You've seen it? All right. All right. So pay attention. Devin, you're on the floor. Okay.
When do you guys want to adjourn? Because I don't want to run too long.
I would say 20 after if possible.
Okay.
And then we can have, that's about 7 or 8 minutes.
And then we can
have some
stick
quick
around.
question and answer. Trust me, folks, this is not something that we're going to have a 3-minute discussion on and say, see you later, bye. This is going to be a discussion that we have every month for many months to come.
But this is the telescope. It was built in 1964. It's a Bowler and Shivens. Yep, here we go. And it was designed to support the Apollo moon mission program to scout out potential landing sites. And so what that means in terms of the optics is it's a relatively slow system. F15.6 is the F ratio on this system. The nice thing is, though, we've been able to do a lot of research with this telescope over the years. With a 10-minute exposure with a liquid nitrogen-cooled CCD camera, we were able to see asteroids magnitude +19. And so we've still been able to do a lot of useful research with this telescope. It was donated to the Academy back in the late 70s. We've had it ever since. And it's been well maintained. DFM Engineering up in Longmont, Colorado, Frank Melsheimer, if anyone is familiar with him and his company, has helped us keep this telescope maintained. We've cleaned the mirror, we've resurfaced the mirror, and we've had them come up for annual maintenance visits with us. So the telescope has been well maintained. It has reasonably good tracking, especially for an Apollo vintage instrument. And the control system is completely computerized, and the control system would be coming with the telescope. So that's the good news. As Matt said, we're looking at removing the telescope in May, about 2 months from now. Reason for that is we're in the middle of the acquisition process for our new 1 meter telescope, and our base contracting wants the site, when we get site visits from the new vendors, they want the site to be bare and to be as it's going to be when the new telescope is delivered. So that's why the telescope is moving out in about 60 days. And the Air Force base contracting is willing to spend Air Force dollars to put this telescope into storage. So that will come free of charge to the Astro Society. And while it's in storage, my intent would be to resurface the primary mirror so that the coating is brand new and fresh. So that's kind of the idea for this telescope in terms of removing it. And again, a little bit of the history. Go forward one slide and I'll give you an idea. Well, okay, so back up one. When we got the telescope originally, one instrument port, axial out the back instrument port, and we realized that's kind of insufficient for what even we wanted to do with it. So back about 4 or 5 years ago, we put a 3 instrument cluster on it, a 3 focuser cluster. And for those familiar with Paul Van Slyke, you might recognize these are his focusers on the back. In fact, these are the last 3 that he sold before the Black Forest fire claimed his shop. So that's the history on those. And so what we have is a flip mirror inside the virtual black box, and you flip it back and forth, and you can go from CCD camera to our spectrograph or any other instrument, take this mirror out, and then you can go straight through to an instrument port in the back. And so that is the current configuration of the telescope, and that will be the way that it stays. So everything, the focusers and the 3-port mount would be coming with the telescope. So that's the current configuration of it. And what's going to replace it, so go forward one, a 1 meter fast tracking telescope. So this will be capable of tracking low Earth orbiting spacecraft across the night sky, including the International Space Station, and also be remotely operable from any laptop around the world. So that's kind of our MO. So this is one of the potential vendors, Lund Engineering, and this is the National Central University 1 meter telescope in Taiwan that they built, and then go forward one. And then this is a 1 meter telescope at Daytona Beach campus of Embry-Riddle University. And DFM Engineering, our current telescope contractor, built this particular telescope. So those are 2 of the potential vendors that we would be looking at for the new 1 meter telescope. To tell you a little bit more about the genesis of this donation proposal that we're working together, Matt and I talked on the phone a few nights ago, and he said, Devin, let me ask you, where did this idea even come from to consider the Colorado Springs Astro Society as a recipient of our vintage Bowler and Chivens telescope? And my answer was, well, a lot of things. First of all, I have a very long-standing relationship with the Astro Society. When I was a young officer on active duty, my first duty station was here in Colorado Springs, and I met Tom DeClue and Paul Van Slyke out at the Black Forest Observatory, and he had a relationship with the Colorado Springs Astro Society, and that's kind of where it all started, and we can go forward one. So that's where it all started. And then when I retired and came to the Air Force Academy many years later, found out they had an observatory there, and started hosting our own, or continuing hosting our own public outreach events at the Air Force Academy. So over the last few years, about every year we have maybe 10 to 15 tours and about 300 to 600 visitors, which pales in comparison with Dave and his tremendous efforts for your club. But security concerns have always been an issue with us. But for some of our larger events, you folks, Tom and Jim Ruchis and Bob Bixby and others have just been instrumental in helping us host a lot of our large tours, where we would break up the scouts or the school students or whatever into small groups and then rotate them through different stations looking at constellations. And then what you folks wound up doing for us is setting up telescopes in our parking lot with the lights dimmed. And that was just tremendous for us, all except for this one poor scout who looks like he didn't dress warmly enough. And so we've just had a great history of collaboration, and I am so appreciative of all of your help and efforts with us throughout the years. And so it just seemed like this telescope donation just really seemed to flow from that relationship and be the right thing to do. And certainly another thing that definitely comes to my mind, flip one more slide if you will, is my memory of Jim West. And he and I just became fast friends and had so much interaction through our tours together. One event in particular here, some of you may remember attending something that we had about 3-4 years back called the Fallen Heroes ceremony. And so this was a ceremony to honor all of the military members at all of the military bases in the Front Range area who lost their lives in service to this country in the Middle East in recent years. And so we had an event organized through Fort Carson at the Air Force Academy Club, and all of the family members, the survivors of these fallen heroes, were invited to attend, and a star was dedicated in the memory of their loved ones' names. And then we had a star party outside, and Jim West was one of the folks who came to participate in that. And I remember a story that he published on your forum following this event, where a young son of one of these fallen heroes came to look at the moon through Jim's telescope and said, "Look, Mom, Dad's up there." And Jim choked up, I choke up when I tell the story, and to me, that's kind of the heart of what we all do, trying to share our love of astronomy with those around us. And so with all of this history between me and the Colorado Springs Astro Society, it just made all the sense in the world to try and make this donation happen. And I advocated that to our Dean of Faculty, Brigadier General Andy Armacost, and he said, "Devin, is that what you're recommending we do?" And I said, "Absolutely." And he said, "Press." So here we are. And we will see if we can make this happen. So that's all I have. How'd I do?
You did great. That's pretty amazing. What you just said really hits home about the impact that we've had. One other thing, if I'm not mistaken, Devin, this telescope does have a Newtonian front end to it?
Correct. Yep.
Can you
And
explain that real quick?
and so the Cassegrain is an F15.6, and I'm glad you reminded me of that. There is a Newtonian focused front end to this that's F4. That is something we have never utilized, but all of those pieces and parts will be coming with the telescope, along with all the counterweights to make it happen, right? Because the whole balancing changes when you start putting instruments on the front end rather than the back. So all of the gadgets will come with it to help rebalance the telescope as necessary. So thank you for reminding me of that.
We only have a couple minutes left, but is there anything that anybody would like to say? Anybody? Yes.
Real quick, and we can talk further about this. Many years ago, when I lived in the Bay Area, I was part of the San Jose Astronomical, and they were offered a 30-inch Newtonian that ultimately wound up at one of the California state parks. And for a lot of reasons, they decided that not only from a liability standpoint, but also, entering into a contractual relationship with the state, they created a spin-off organization, what they call the Fremont Peak Observatory Association. And that actually proved to be useful for a number of reasons, even though it was still associated with SJAA. So just a thought.
I think that is a wonderful idea. These are the types of ideas that we need to have in these committee meetings. We have a lot of things to discuss. I know there's a lot of members that Rick Angel was here earlier, has a ton of experience with clubs in New Mexico that partnered with a state entity, such as the State Park Association. They've put them up all over the place. So there are options available. The Minnesota Club has done that. They've partnered with state entities. They also have their own private one. One thing, though, that I've seen that's almost been a constant in all of these discussions of having perhaps an observatory with perhaps a classroom, maybe 2 observatories, maybe 10. It always appears to be some sort of government agency that helps make it happen. Now, whether that's good or bad, we'll have to be judged in our area, but that's kind of the way it is. Any other quick comments? Okay. In closing, from what I gathered, it appears that it is worth our time to continue this discussion. Am I correct? Yes. All right. Another thing I need to ask this membership, our board is busy. I'm busy playing president. Dave is busy playing Mr. Outreach. Jim is Mr. I need to find speakers every month. We're busy. So the question I have for the membership is, in order to make this happen or something happen, are you willing to make a commitment to make it work? Because this board is fairly tied up. We need more active member participation to do it. If we can't get that, it falls flat on its face within a matter of months. So that is what I want to leave you with, something to think about. Can you make the commitment to make this happen? There's a lot of things that we can do. We just need to talk through them and see where this leads us, because it could be a really interesting ride.
Hey man, do you want maybe somebody, if anybody's willing to stand up, to be willing to head up a special interest group specifically for this effort?
Yes, we are going to be needing some sort of a leader for this group. Preferably someone that has good speaking skills, someone that has good communication skills, that is not scared to speak in a public environment, because I have a feeling that this will get to a point where we'll be speaking at county commissioner meetings or city planning meetings, or perhaps park boards or something like that. So yes, we are looking for that. Obviously, I don't want any if I have volunteers today, that's great. But really what I'm looking for is for you to think about it, think about the vision of this club, where we're going to go, if we're going to go anywhere. That's really what I'm interested in today. Okay? Cool. That's all I have. Thank you. Real quickly. Fred still wants these filled out. No, there's a meeting after the meeting at the Village Inn, which is right down the road here. This one after.